Okay, I botched the last homework problem so bad that I just deleted that one. I might be a little bit late to a meeting I've got to be to at 5:30 here because it's 4:30 right now. But anyway, I was like, wait a minute, that's the beauty. That's the beauty of doing this. So of this is you get a do-over. You can say, all right, you guys don't know that I'm an idiot. Well, maybe you do. All right. Well, here's a problem. Here's one of your homework problems, and it's hard, and I should probably make it. Anyway, let's say I've got a charge here of -2 microcoulombs, and here's the origin at 0, and then I've got a charge here of -4 microcoulombs. Now, of course, mastering physics doesn't give you problems that are that nice and, those nice of numbers or anything. Now, which direction are the electric field lines going on? Well, they're coming in. So at the origin, and let's say they're 0.5 meters away from the origin. Let's say they're 0.5 meters away. All right, so at the origin, there's, and this is charge 1, and this is charge 2. So E1 is going this way, and E2 is going this way. And a better question than the one that they asked, they wanted to find out where the E field, somewhere on here, is the E field going to be 0? Well, right here, this vector is going to be much bigger because this charge is bigger, so the electric field is going to be bigger. So as I get closer to here, where this one gets, there's going to be a point over here where this one's going to be like this long at this point, and E2 is going to be this long, and I've got to find that point right there where they're equal, so where E1 is equal to E2. And that's going to be on the left-hand side of the origin. I totally screwed that up when I was first explaining it to you. Okay, because you got to remember, vectors are, E fields are vectors. And this one, because this charge is bigger, and the distance between them are the same here at the origin, then that's why the 0 part is going to be over here. All right, so now, how would you even go about finding where this point is where E1 is equal to E2, where the two fields are equal to each other? Well, you do, and I'm going to go ahead and cancel out. Well, what I'd say is, the way I would do it is, I'd go, okay, fine. Let's take the total distance, 1.0. So I'm going to find this point right here, x. Okay, here's 0.5, which is right in the middle, which we'd call 0, which lines up with 0. And say, let's find this distance x. Well, then what's this distance? 1 minus x. There you go. So E1 is equal to the absolute value of E1 then is equal to k q1 over x squared, and E2, the absolute value of E2, is equal to k q2 over 1 minus x squared. And that's the way you go about it, and then it just turns into an ugly algebra problem. But that's the way you kind of evaluate. Now, would you be asked to do a question like that on the exam? Are you crazy? You might be asked to do a question on the exam where you have two charges that are separated by 0.1 meters, and you've got an E field at 0.03 meters. This charge is 3.0 microcoulombs. This charge is 5.0 microcoulombs. Okay, and then this would be, of course, this is 0.07 meters. So you add the two, so you get the total. Let's find the E field here. If they're both positive, so this one, so E1 would be going this way, and E2 would be going this way. And so you'd calculate what E1 is, make it E1 would be positive. E2 in this case would be negative because it's going in the negative x direction. And so you'd say E1 magnitude-wise minus E2 is equal to, well, take the sum of the E1 plus E2. But you have to be careful with the positive and negative signs. Okay? All right, that's a much better rendering than what I did before. Out here, that's it.